All right. So let's finish this. I just have, you can see actually the numbers right here. I just have a few slides left for HDFS, and then we'll move on with the syntax for denormalized data. So I was saying that we have these URL schemes like this. You see HDFS, there's actually a lot of them, the other schemes than HTTP. HDFS is here. There's S3, S3A, S3N for Amazon S3. There is file : / for the local file system, and so on and so on. FTP, you might know, for a file transfer protocol. So, you know, we just keep adding them. But in the end, it means that any file you have can be referenced with a URL like that. You can continue here after the host / and directories and the file name, right? This is super useful when you want to connect to different file systems with the same tools. And in fact, what I was showing to you here I put some absolute path in here, but without the scheme. It starts with a /. Why is that? That's because I have a default file system. And that's what I was explaining, that you store in here. You have the default file system that says it's an HDFS cluster. And this is why, since it's configured in this way, this is interpreted as an HDFS location on that server, right? So this is why we have. But if you want, you don't need to have a / here. You can also put HDFS or S3 or anything else basically here, and it will also connect to read and write from there. Of course, this is assuming you have the credentials, right? For example, HTTP, you might be able to read, but not to write, obviously, because you cannot just write to a website, right? Even though there's extensions of HTTP that would allow that. But technically, PUT does this, but you cannot do it without any proper authorization. That's what I mean. All right. Then you can configure the replication. You can configure the location of the name node data, the data node data. So here we are talking about the physical files that are on the local drive of the name nodes and data nodes. So if you want to play, if you have an opportunity, maybe you can play with the Docker that is given to you that has some sort of simulation of HDFS. But if you want to create clusters on Azure or on Amazon, you know, sometimes they give you free credits to try things out. It's just a few clicks of a button to create an HDFS cluster. So you can do it, you can play with it. Then you can even SSH yourself to the machine. And then through SSH, then you go to this location on the local drive. You will actually see the blocks. The actual files of the blocks, they will be there in this location. All right. And then there's a few additional tools that people like to use. For example, there is Flume, which is a way of collecting log data into HDFS. Why is that a good idea? Well, it's because I told you HDFS is not for random access, but HDFS is very append friendly, right? If you append at the end, then that's fine. And logs do exactly that. When you have a log, you just add the new lines at the end of your log. So you can also aggregate, move over, and so on. And then there is a second tool that's called Apache Scoop, which copies over relational data to HDFS, right? It copies over the data from your relational database to HDFS. So in essence, that's the data lake, right? We're talking about HDFS is a data lake, S3 is a data lake. Of course, whether that's a good idea or not, you need to figure it out, right? Sometimes that might be a bad idea because the relational database was the better way to deal with the data, but there can be use cases in which you want to denormalize your data or maybe put it alongside some more data, and the scales are so enormous that it kind of makes sense. But the goal of that course is to give you that feeling of when it makes sense and when it doesn't make sense, right? But the rule of thumb is really that, from what I see when talking with people who say what they do in their companies or startups, is that in a lot of cases, what you're looking for is a relational database. And that's also a database system. That also applies to a lot of people who are working on blockchain stuff. A lot of people who say, oh, I'm working on the blockchain, they need a relational database management system. That's all they need, right? And blockchain is just somehow the new hype. Well, technically, 10 years ago, the hype was key value stores. Everybody wanted a key value stores. And again, the people using the key value store actually needed a relational database management system. But since everybody was rushing in key value stores, then yeah. So now the hype has passed. It's blockchains. In 10 years, there's probably going to be something else that people will rush into. And again, we'll tell them what you actually need is a relational database management system. But I guess this is how things are. And you'll be the one telling them, then hopefully. All right. What do I have? Yes, I have this warning about the vocabulary, just so that that you know, be careful with this. Name node in GFS, so that's the Google file system, the proprietary version, they called it a master. The data node, they called chunk server. The blocks, they call chunk. The FS image, they call checkpoint image. The edit log, they call operation log, and so on, and so on, and so on. And to top it all, the size of a block is 64 megabytes and not 128 megabytes. Some implementations of HDFS also use 64 megabytes. But again, what matters is the order of magnitude. If you tell me I'm using HDFS and my block size is 4 kilobytes, that's not okay. If you're using HDFS and you're telling me in 2023, our block size is 10 terabytes, that's also not okay, right? It's really this order of magnitude that will evolve, of course, over the years. So now Azure is already communicating that they use 4 gigabytes as the size of a block. So you see this is slowly increasing, but this is what's important is the order of magnitude. And here too, of course, the words are useful because you need to communicate with other people, right? So the words need to be consistent. But you really need to have an open mind for the fact that, that different technologies will use different names. What you need to understand is the actual technologies, right? What they do. And then it's just about reading documentation when you want to know how it's called. All right, there is, I will check if we put just as an optional read the GFS paper. There's also an HDFS paper. That's the official documentation. It's actually quite good. You can really read a lot of additional details on that if you want. We have a Java API. If you're interested in a Java API, there is also a REST API for HDFS. So you have plenty of things that can interest you. But you also have the textbook, of course. So the mandatory reading is the textbook, and maybe we'll throw in 1 or 2 papers in there, but all the rest is optional. That's really just up to you. It doesn't mean you shouldn't read it optional, of course, because if you read optional content, it helps solidifying the knowledge in your brain because you expose yourself to this world, right? So it can still be useful, even if you don't know it all by heart. So I'm going to interrupt the recording right here for HDFS, and then we'll move over to syntax. So see you on the other side.